So today in the isomerism we take one or two topics like EZ nomenclature, this is in the alkenes we have initially cis trans. So this is in the place of cis trans isomerism. So prior to the new method, we used to have a cis and the trans method. An example like a methyl and hydrogen. These two methyls are same side. Similarly, even the hydrogens also same side. So either by taking the methyls or by taking the hydrogens, cis is used for the same side. So this compound is called as cis to butene. Okay, right. In another compound, let us take, we have two ethyls one side, one methyl and one hydrogen. Now if these two are different, but the ethyls are same, so therefore it is once again said as a cis compound. Taken grant that the two ethyls are same side. If all are different, for example like this, one is ethyl, one is a propyl, one is a methyl, one is a hydrogen, then also the cis trans can be extended. Taken grant this is the main compound, right? So the main compound is same side, therefore it is cis. That means when two references are there, or if one reference is there, or if no reference but still the organic compound is taken as a basis, and then the cis and trans. The two methyls opposite naturally we call trans. Like for example, if the two methyls are there, this is called trans type. So trans to butene, cis to butene, it is the method. That is, we say first cis trans, then followed by the 2-butene, that is IUPAC nomenclature we are extending. But longer time this method we are using. But a compounds like for example, if all are groups like a chlorine, bromine and iodine, fluorine are there. Now is it a cis compound or a trans, means which two should be taken as a consideration and then say it is same side, opposite side, means it is slightly difficult when all. It's not, main compound is only 2 carbons, right? So for this cases the method has become a slightly difficult. Even then you can extend that the bigger the group, smaller the group and so on. But in where this cis trans has got some confusion, the new method, that is EZ nomenclature, has come into the existence, and however this has no such drawbacks now. So let us see how this EZ nomenclature is extended. Taken grant from the first member, in this EZ nomenclature, the group's right side and the left side individually allotted a priority number. A priority number is allotted. What is this priority number? Means based on the CIP rules. There are some rules given by this 3 scientists, that is Kahn, Ingold and Prelog. The 3 scientists made some rules like the priority is given based on the first point, atomic weight of the element, of the first element, that too. Based on the first element atomic weight, so here the carbon is there, here hydrogen. What after that hydrogen is there, but that's not the criteria. First element carbon, first element hydrogen. Which one is having the higher atomic weight? The atomic weight of the first element, heavier one, given a first preference. So this is given 1, this is given 2. It is not the atomic number. Why atomic number? Instead of atomic number you can select. But there are some cases where one is hydrogen, one is deuterium. In such a case also we can extend. Both are hydrogens, atomic number is same, but the atomic weight is, deuterium is more. So therefore in this case this is given 1, this is given 2. So after giving the numbers to the one side, the other side also 1 and 2 is given. So atomic, sometimes this is the carbon, this is the carbon, both are carbons. In such a case, next element will be considered. Here the next element is hydrogen, here is carbon. Therefore, this is given number 1, this is given number 2. Like that, element by element you have to go. First element, if a competition tie up, then second element is considered, third element, like that. There are number of groups we can examine. A OH is a preferable one over a carbon. Let the carbon contain the 3 carbons, 3, that is 12 into 3, 36, but this is only one hydrogen. But the element oxygen is that is overweighing over the oxygen, 16 and 12. Therefore, one OH is a preferable group over the tertiary butyl. As a whole, it is bigger one, but the oxygen versus carbon means oxygen comes first. So like this, there is a big series based on this criteria. A double bond is considered as a almost double, 2 times or 1.5 times at least. Like that, the element by element we are going on. At somewhere the tie breaks up and we consider the first preference. And like this, first preference, second, first, and if the 2 firsts are same side, so we are extending this Z for this one. Z for the meaning in the German language we have taken zusammen. Zusammen means same side. If the groups are same side, we are extending the letter Z. So therefore, this compound name is given as, we have taken 2-butene, but at 2 we have a Z configuration, 2Z-butene. 2-butene, but at 2 what configuration is there? Z is there. Previously, cis we used to use in front of the 2, cis-to-butene. Instead of 2-cis-butene, we used to say cis-to-butene. Now after the 2, in the brackets that Z is given, Z says same side. What are same side? 2 number 1 preference groups. From here number 1 preference, from here number 1 preference is same side. Therefore, we are extending the Z. Similarly, if opposite is there, for the trans compounds majority time E comes. E stands for the entgegen. Entgegen means opposite. When the groups are opposite, like trans compound, so a butene having the 2 methyls opposite, then originally it was called trans to butene. Now this is number 1 group, this is number 2 group. So number 1 groups are opposite, number 1 opposite. So leave the number 2, but the number 1s are opposite, therefore it is called. At second carbon we have a double bond which is opposite configuration, 2E butene. So this is the nomenclature we are extending. So with this E and Z, all the alkenes without any problem. As I said, we have seen a compound which is having the chlorine, bromine, iodine, fluorine. Without any difficulty, out of these 2 groups, this is number 1, this is number 2 preference. The chlorine, bromine is number 1, chlorine is number 2. Therefore, so this compound is called as a 2 ones are opposite. Therefore, we are giving the so E configuration. At which carbon means it is a ethene only. So the number need not to say, it is a E ethene. Having the number 1 opposite. So alphabetical order, that is A, B, C, D. So number 1, number 2. So at number 1, what are the groups you have to say? At number 2, what are the groups you have to say? At number 1, 1 bromo, 1 chloro, 2 iodo, 2 fluoro, or alphabetically arrange all these groups and say ethene it is. It is a E ethene having so and so groups at so and so position. So all that groups will be prefixed, giving their locating numbers, and then said ethene. So this compound is E because 2 number 1 groups are opposite. Okay, ethene. Mostly the cis compounds happens to be Z, and trans compounds happens to be E. But there is no such a, if that is the case, the new methodology will not come at all. So we have some examples where E goes to into this type of the nomenclature also. So let us take one example like this. One side you have a ethyl, one side methyl, the other side we have a propyl or N-butyl and the isopropyl. Now here that is old method, cis-trans nomenclature is there. In the old method, this is the main compound, that is instead of propyl we take butyl as the main chain, and these two groups are considered as the bigger groups, therefore I call it is the trans compound. It is a trans compound. At second carbon we have a trans, therefore it is a trans 2, 3, 4, 5, 6, 7, 8, 2 octene. And these two groups are mentioned as methyl and isopropyl at second and third carbon. And second and third carbon, some groups are there, 2 methyl. At third carbon we have a isopropyl, third and fourth we have. At third carbon we have methyl. At fourth carbon we have isopropyl. It is, if it is not allowed, you can say 1 methyl ethyl at the fourth carbon within the brackets, branch with branch type you can add. Say it is a trans 2 octene, 4 plus 4 octene. Now the new pattern, it is the EZ nomenclature when you apply. Out of these two, this is number 1 because carbon-carbon competition tie-up, next hydrogen, next methyl. So this is number 1, that is number 2 group. Out of here, the carbon-carbon tie-up, then next we have 2 carbon, there is only 1 carbon. That has a next, that is not a. So immediate carbon, first carbon tie-up, second carbon we have 1 carbon, second carbon 2. So this is number 1, this is number 2. Now the two number ones are same side. So therefore we have to extend these groups you can use as it is. But you have to say at second carbon we have a Z configuration. So therefore at 3 we have a Z. So at third carbon we have a Z nomenclature. So 3Z octene. So finally what we are observing is a trans compound in the old nomenclature. In the new nomenclature it is Z compound. That means it is not correct to say that all cis compound will become Z, because Z is same side, the cis is same side, but trans compound is now in the latest new nomenclature, it has become Z. The Z is with reference to the two priority, number 1 priority groups are same side. In the previous case, big size groups are opposite, therefore we have used trans. There the butyl is important over the isopropyl. Now in the latest nomenclature, isopropyl is important over the N-butyl. So therefore the discrimination has come. However, the cis and trans method nomenclature is, it's not a comparable one actually with the EZ. The EZ is an almost a absolute one, without referring to the back given compound can be applied this Z and this one. So the latest nomenclature is EZ nomenclature. Similarly, we have another nomenclature in the optically active compounds also, that is RS nomenclature. So prior to this, the RS nomenclature, we have in the compounds like glyceraldehyde, that is structure identification type of nomenclature. When the molecule is written in the Fischer model, this is the only one chiral carbon. In case of many also, the bottommost chiral carbon important group is right side, we used to say capital D. Capital D is not connected with the property of the compound, but it is connected to the structure. So this is called D, capital D glyceraldehyde. Its mirror image will have a OH this side is called a capital L, left side is L, right side is used capital D nomenclature, right. So this is called DL nomenclature. Based on this, for example, if this is reduced to CH3, this is oxidized to COOH. So from the glyceraldehyde, somehow by reduction and the oxidation methods, 1 and 2 methods if you apply, the compound will become into COOH and methyl. The OH and the H will be retained. So that is these 4 bonds specifically we are not touching or breaking. Without breaking these 4 bonds, this group is converted. Beyond that carbon, the other groups are oxidized, this side groups are reduced. So this will become into a lactic acid. Now taken grant the earlier compound has a capital D, without seeing inside of the compound, you can say extend, this will become a D lactic acid, because it is arised from the glyceraldehyde. This type of extending the nomenclature from standard one compound glyceraldehyde, the all other compounds are somehow derived without breaking the main bonds. That is, the structure is understood the same structure orientation. So therefore we have given extended the D. If it undergoes any substitution, like let us say SN2 reaction, in SN2 100% inversion takes place. So D compound is understood to give the L compound. In SN1 50-50 takes place, or in a neighboring group effect, or SNI intermolecular type of the configurations, 100% retention takes place. So we have to understand the mechanism, what type of, is it retention or inversion taking place, and then we extend this D to D means there is no breakage. So therefore 100% there is no change in the D, so D will give D only. If inversion takes place, D will give L. Like that we extend. This is all called what? Relative nomenclature, or taken grant one compound configuration as a standard. Based on that we are deriving the other compounds nomenclature. Therefore this method was there initially, but recently the method has come which without any referring to any compound. If one compound is given without any reference, we are going to give assign the that is nomenclature, or the methodology where depicting the symmetry or the structure of the compound. This is the one, another method called RS nomenclature, is also called a absolute method. Without referring or connecting to other compounds, we are giving, therefore it is called absolute method. So the extending to this the DL nomenclature, that is a relative configuration. Here this is a absolute method, RS method. An example, if you take an aldehyde and alcohol groups containing one OH on the right side, H, this is called glyceraldehyde. So in the old method the OH is right side, therefore we call it is a D-glyceraldehyde. However, in the RS nomenclature, all these 4 groups are attached to the chiral carbon is numbered as 1, 2, 3, 4. So based on the again CIP, that is Kahn-Ingold-Prelog rules. So the atomic weight is the criteria: oxygen, carbon, carbon, hydrogen. So the number 1 is oxygen, heavier atomic weight for the oxygen. Both are carbon. There is a tie-up between the second and third. This happens to be a 4th group anyhow. So second and third is tie-up because carbon, carbon. The carbon is attached to doubly to the oxygen, singly to the oxygen. So therefore 2 is given for this one, 3 is given for this one. So all the groups are given 1, 2, 3, 4 priority numbers. So let us avoid the confusion and write only the number, so that confusion will be less now. Now after allotting these numbers, then get the 4th group, that is least preferable group, to the bottom. Even to the top also you can. It must be brought on to the vertical line, that's what. Simply bring to the bottom. By having a exchange, you cannot put the two groups, isn't it? So 3 goes there. So one exchange will give a wrong answer, and the opposite group should not be exchanged. Only sidewise groups only you have to exchange. So let exchange 1 and 2 also, so that 2 number or even number of exchanges will retain the same configuration. So after exchanging, groups will be like this. 4 has come here, 3 has gone there. So again 1 has come here, 2 has gone there. So after exchange, these are the groups now. Now after exchanging, leave the 4th group. That means think that the 4 is not there in the picture at all. So read 1, 2, 3. Read 1, 2, 3. Your eye goes in the clockwise direction. That is, in the clockwise direction, if it goes so it is a right-handed side, right? So it is going right-handed side. So therefore it is called a R compound. R stands for, in the Germany, rectus. Rectus means right side. So the R symbol is given for the, not from the right R, it is actually the German word rectus. First letter is taken as a R. So therefore whenever this 1, 2, 3 groups are in the clockwise direction, you are calling this is R. So therefore let us call R glyceraldehyde, because only one chiral carbon, you need not to mention it. Second carbon we have a R, only one carbon, therefore let us use R glyceraldehyde, that's all. Okay. But if more carbons are there, we have to say at this R is at second carbon, so 2R, 3S and so on. In this case it is okay. Now let us take one more example. I have a chlorine at the second carbon, right? So is it a R compound? Yes means unless you mention it's the either in one of the model like 3D model or the Sawhorse model or Newman model or in the Fisher model, that is specifying the groups in which direction they are. You cannot decide whether it is R or yes. So first let us write this molecule, convert into the Fisher model. That means if you number this compound, it goes like this. So the number 1 carbon goes to the top always. So this carbon you bring it to. So the whole group you can write ethyl, C2H5. So at this carbon only we are giving the preference. So let us write chlorine as a default first right side. Okay. Then this compound we decide whether it is R or S. There is one more compound, its mirror image will be the another isomer. So extend this. So out of these 4 groups, the chlorine will be the number 1 group, hydrogen will be the 4th preference. Methyl, ethyl, again carbon is tie up, but the carbon has one more carbon, so therefore it is second group, this is third group. So write this 1, 2, 3, 4, 1, 2, 3 and 4. After exchanging 1 versus 3, 2 versus 4, the idea is getting the 4th group to the bottom. So 4, 2 and 1, 3 is exchanged. Now leave the 4, read 1, 2, 3. It goes right hand side, left hand side. So whenever it goes anti-clockwise, this is anti-clockwise. Anti-clockwise means it is left side going, so therefore it is called S. Instead of L we are using S, we are using S stands for the sinister. The sinister in the German language, it is left-handed meaning. The compound is left-handed. So therefore I am using the S compound. So this compound is not this one. This compound is now S2-chlorobutane. S2-chlorobutane. Or better is, after saying the 2, in the brackets say S. So better is a 2-chloro. You can say like this, but systematic method is number of the chiral carbon will be mentioned. In the brackets its configuration, it has a S configuration, therefore so 2S 2-chlorobutane, 2S chlorobutane, 2 need not to be said once again. 2S chlorobutane is the, its mirror image will have the that is a 2R the butane, chlorobutane. So that is, if the question is write the structure of 2s chlorobutane, this is the structure, okay, right. In the Fisher model it is there. It is not necessary in the Fisher model actually. Let us practice some more compounds, and what exactly the idea of that Fisher model means we will see. A carbohydrate containing the 4 carbons will have the 3 hydroxy groups and 2 chiral centers. These two are not identical or not divisible into 2 halves. Directly you can apply 2 to the power of n, therefore 2 to the power of 2, that is n is equals to 2, therefore it is called 2, 2, that is 2 into 2, that is 4 isomers are there. 4 isomers means 2 pairs we are going to get. Let us write all the compounds here briefly. So the aldehyde is common, 2 OHs the same side, right. So in the old nomenclature we say it is a erythrose with a capital D erythrose. OH is right side, therefore D erythrose, old nomenclature. Its mirror image will be the L erythrose. OH is left side, so therefore this is representing the L. So the other OHs we are not concerned. Same side means erythrose, both are D erythrose, L erythrose, old names. Now as a default let us keep the first D1, D but opposite. So this is called what? D triose. Its mirror image will be the L triose. OH will be this side, OH will be that side. But IUPAC name of this compound will be the 1, 2, 3, 4. So 2, 3, 4 trihydroxy. 2, 3, 4 trihydroxy butanol. Butanol aldehyde. At second and third we have chirals, therefore at 3 and 4 we are specifically, we have to say whether it is R or S configuration. The differing that configuration we have got the 4 compound. What is the RS nomenclature extension to this particular compound means? Let us decide the first at second carbon and later at the third carbon, okay. At second carbon we have groups now. So decide only the second carbon. So at second carbon we have a number 1 group OH. Hydrogen will be the number 4th one. This side we have carbon, that side carbon. Carbon with double bond, so therefore second group. Carbon with 1 oxygen, 1 carbon will be the third group. So exchange this. After exchanging 4 comes here, right. 3 will go here, 1 and 2 also exchange it. Now the closing the 4, read 1, 2, 3, it goes to the clockwise, therefore it is 2R. At second carbon we have a R configuration. And the third carbon is a mirror image of the first one. See, isn't it? A mirror image almost at it. So even then we will decide it at third carbon what is there. At third carbon we have a number 1. Again we have to apply this. So this is number 1 carbon. Number 2 will be this carbon has a 1 oxygen, 1 carbon double bond. 1 carbon, 1 oxygen. Here carbon plus oxygen is also there. So carbon with oxygen, but common carbon is not there. Another carbon is there. So the downwell will become 2. This will become 3. This will become 4. Exchange and then see 4, 2, 1 and 3. So you have a 1, 2, 3. So therefore it is a S. That means this is a 2R and 3S configuration. 2R, 3S configuration. Coming to this side also. Now this will be the mirror image of this one. So at second we have a R configuration, S configuration. Mirror image to the R1. And it is a mirror image. So therefore it is a 3S, it is 3R. So 2R, 3S is first compound. 2S, 3R is second compound. And now this compound is it is similar to this type of compound. At carbon, same compound. So therefore it is 2S and the 3 will be similar to this one. So this is 3S. 2S, 3S it is. And in this compound it is At second carbon you have a R type of configuration. Third carbon is a to the R type, so 2R, 3R. Okay. Now the with 2R, 3S combination, 2R, 3R combination, 2S, 3R and 2S, 3S. So all the four compounds have different types of the designation, and remaining carbons chirality is not necessary to mention. Therefore, at specific second carbon, what is the symmetry means? It is the R symmetry is there. Individually, isn't it? That is not influencing this one. Once you have to implement the R, yes, for the second and also third. Like that, you are extending the RS nomenclature to the more than one chiral carbons. If it is Fisher model, the fourth group better bring to the bottom or to even to the top also. That means vertical line. The fourth preference group must be brought to the vertical line. Why should I get like that? Means the two groups are in fact it is towards you, isn't it? Two groups are going backside. The idea of a fourth group bringing down means two are towards you, this is backside, this is backside. That means when the 4 is here and other group is backside, you are catching the 4 in your hand. That is, there are two groups towards you, this is going back, this is going. So fourth group you are catching, and these three groups just tilt like this. All the three will be projected towards you. When fourth is backside, 3 are towards you. Just like imagine there is a flower with the 3 petals and a stalk. The stalk is unimportant, holding the stalk. 3 petals are there. These 3 petals numbered 1, 2, 3. If the petals are arranged clockwise, call it as a R. If the petals are arranged anti-clockwise, that is 1, 2, 3. 4 is in your hand. What is that 4? It is less important. Less important is in your hand. Originally, the 2 are towards, the 2 are backside. One backside, one you caught it and then twist like this, so that 1, 2, 3 comes into a circle. This circle will have a clockwise or anti-clockwise arrangement of this 1, 2, 3. So what exactly RS nomenclature is? Reading the compound, one compound you are reading from the rear side of the least preferable. This is the least preferable, fourth group. Fourth group back side you are coming and reading. What is this back side called? Means rear side. So read the compound from the rear side of the least preferable group. This is fourth group. Fourth group opposite side you are reading and you are calling this, is it clockwise or anti-clockwise. So that means the fourth is here means you just fourth, isn't it? Fourth is just twist it or make it disappear so that only 3 are visible and the fourth is backside. So read 1, 2, 3. If 1, 2, 3 is like this, it is clockwise, say it is R. If it is anti-clockwise, say it is yes. So reading the compound from the rear side of the fourth or the least preferable group and calling it is a yes or yes. So like this, any compound, you need not to go to the Fisher model and so on. For example, I'll give some examples where is a cyclohexane containing 1 methyl. Here there is 1 hydrogen and 1 chlorine. Now, in this compound you have one advantage. What is that? At this carbon, I am asking the symmetry. At this carbon, is it R or S? Now, one easiness is this is the fourth group. Hydrogen will become fourth group, isn't it? So, what are the 1, 2, 3 groups means? The chlorine happens to be the first group. Carbon with carbon, carbon with 2 carbons. So, this is the second group. This is the third group. This is the fourth group. So, fourth group is already backside. When the molecule is written like this, 2 and 3 bonds are on the plane. These 2 are on the plane, just like board. This is in front. That means when these 2 groups are in plane, this comes in front of the board, that goes backside. Already 4 is backside. That is fourth preference is backside. So you look from this side and read 1, 2, 3. It is very easy. So you need not to go to the, not necessary to go to the Fisher model at all. Already the molecule is slightly, it is in favor of you. 4 is backside. So you are reading from this side opposite to this fourth group and reading 1. So 1, 2, 3 goes in a anti-clockwise. So therefore it is S configuration. If the compound is like this, for example, that means the hydrogen is in front of the board and the chlorine is backside, let us say. The same happens to be, so this is 1, this is 2, this is 3. Now the hydrogen is this side. That means you have to read from the back side of the board, isn't it? So why should I go from that side? I read from this side only, isn't it? I read from this side only. I give the answer in an opposite way. So let us see from this side what is that? It is anti-clockwise. It is looking from this side, isn't it? It is looking as a yes. But correct answer is R, reverse answer, because you are looking from the side of the fourth group side, you are looking, not from the, otherwise you have to come from the back side and see that the groups are projected back side, isn't it? So these two in plane, that is back side, so you have to read from that side, or I will read from this side. They can grant that other 3 groups are like this. So from this side if it is S, the other side it will be R. Therefore at this carbon you have a R that is reverse to this. These two are naturally so enantiomers, isn't it? So like that a given compound, when it is even moving in the air also, or whatever the model it is, for example, if the model is written like this, in a sawhorse model it is written, okay, in a sawhorse model it is written. That is also, let us have some, in the sawhorse model we are using some 3D model also. So these two are OHs, let us say. This is CHO and this is CH2OH. This molecule is nothing but, from this side if you see, from the side of the all the 4 groups if you see, the 2 OHs happens to be left side, that is this compound and this compound will be the same one. From this side if you see, both the OHs will be this side, so therefore it will come like this. This is the molecule also, the 2 hydrogens and 2 OHs are towards you, and this is back, this is back. That's what the same molecule, this and this will be the same. So let us implement and get the same answer, then you are able to understand, isn't it? Then you able to understand. So therefore now let us decide the configuration at the second carbon here. So the 4 is already backside, these 2 are on plane, this is towards you. So let us designate the 1, 2 and the 3. So this is already backside, so therefore you can as such go to the implementation. So 1, 2, 3, it is anti-clockwise, therefore yes. That means at second carbon you have a yes. Verify it, it is yes only, say right. Now here also the hydrogen is backside, isn't it? Hydrogen backside, this is 1, this is 2 and this is the third group. So 1, 2, 3 opposite going. This is that is clockwise, it is clockwise means it is R. So that is at third carbon we have a R. This and that, whether you write in this model or that model, understand carefully that the least preferable group should be backside. That is, you are making the molecule like this. Fourth will be backside. 1, 2, 3 are towards you, projected towards you. Read 1, 2, 3. Taken grant 4 is not there in the picture. Or people also can do. So the 1 you can go back, read 2, 3, 4. Isn't it? 1 also can be sent back. That means when 4 is on the top, for example, if the 4 is on the top, 1, 2, 3 is there, you can twist backside. This is anyhow back only. Read 1, 2, 3 only, isn't it? That also gives the same. So whether the 4 is on the top or bottom, you can go head. But if the 4 is sidewise, it gives a slight confusion. Therefore, bring the 4th to the bottom is a general rule. But you can take the 4 to the top also. If it is already there on the top, you need not to do any exercise. Read just 1, 2, 3. 4 is already down. You need not to do any exercise. Read 1, 2, 3. That's all. Like that, whatever the model it is given, the concept is very clear. The 3 groups, that is important groups, are towards you and the 4th group is backside. Therefore, you need not to consider 4 at all. Read 1, 2, 3. That is, they are brought into a circle. in the circle the 1, 2, 3 clockwise R. So, that is what the RS nomenclature. It is absolute method because we are not having taken any reference of other compound. At one chiral carbon, what is the arrangement? Is it right handed or left hand? Just like the C shells, right handed shells, left handed shells. So, in a given two compounds, R compound, S compound, they are all mixed. By seeing, you can say, oh, this is right handed one, this is left handed one. That is what the application of this RS nomenclature.